Alright, so in this video we are going to be tackling the problem of knapsack, coin change and coin change 2. So let's first of all discuss what is the knapsack problem. In the knapsack problem you can think of yourself as a robber who decides to rob a house. So I will draw a robber, a very happy robber, and he is deciding to rob a house with his bag which can store some amount of weight. Okay, let's say that he can only store 8 kg of weight, and you have different items in your house. You can maybe have a golden banana, you can have an apple, and maybe like a small pot with some plant over here. Okay, and each of these items will have their own weights. So I can say that my weights could be like around 3 kg, 4 kg, 5 kg, and each of these items will also have a value associated with them. So my value would be either 30, 50, or 60. Now it's your job to collect as many items as you can such that you have the maximum value, and that you cannot exceed your bag threshold. So what I mean by that is you cannot choose both 3 kg and 4 kg, because this will be 9 kg and your bag cannot hold 9 kg of weight, so you can't do that. So over here we can see that if you get this item and this item, this will be 30 plus 60 and you will get 90. So this will be the maximum value that you can get. Okay, so this is what the question is asking you to solve. Now you can't actually apply greedy, because if you apply greedy in terms of your value, then you will see that you will find an error, which is that you will go out of bounds. And even it's not necessary that your least kg item will have the least value. It could be possible that this could be like 90. So the greedy search will not be applicable over here. So we need to do some sort of recursion to brute force all of the possibilities and then find our answer. So now that you've understood the question, let me now try to explain you the recurrence tree. So the weights are going to be 3, 4, 5, and the respected values are going to be 30, 50, 60. Your indices of this is going to be 0, 1, 2, because this is an array weights and array values. So if we are trying to figure out so we'll be going top down approach, which is right to left. So if we start from f of 2, right? So at this item, if we think about this, we have an option to either take an item or not take an item, right? Pick an item or not pick an item. And similarly here, and similarly here. And if we can pick the items in such a way that we do not exceed, if we do not exceed our um target weight, then that will be our answer. So our target weight is going to be 8. So what I could do is I can have my position of a weight or of an item, and I can have my target weight, which I'm going to say my current weight. This will be 8, and then I have an option to either pick an item or not pick an item. So if I pick an item, then I have chosen this item. I will first of all subtract the value of its weight from my current weight. So this will be 2 comma 3, and I will sorry comma 3, and now I will decide for this item as to whether I should take this or not. So again I will have pick and not pick, and I will move on to the next item, which is going to be 1. Similarly, if you take a look at the not pick conditions, and then I decided that I won't be taking this, So my weight will remain the same, but I'll decide for this item as to whether I should pick this item or not. So either pick or not pick. Okay, very simple, very easy. Let's do one more, and this will be if I decide to take this item, what is going to be my weight? My weight is going to be -1, and I am going to go to my 0th item. So this will be 0, and then if I don't pick this item, then I'll be at 0 and my weight will be 3. Similarly over here, this will be also 0, this will be also be 0, and if I pick an item, so 8 minus 4, that will be 4, and then 0, if I don't pick this, then it will be 8. Alright, so we are going to stop over here, and I will be explaining as to why I stopped, why I'm not proceeding to another branch of the tree, and like I also have like two options over here. I can pick this item or I can skip this item, right? But I'll be explaining you as to why I'm not going into more depth over here. Okay, just bear with me. So if you look and try to examine the recurrence relation over here, so we can see that if we are taking an item, the index I is always going to decrease. So I can say that if I decide to pick an item, I will be calling a function for I minus 1, and my current weight is going to be decreased to whichever weight I was currently at. Okay, very simple. If I look over here at not pick, again you'll see that the index is being decreased by 1. So this will be not pick I minus 1, but my current weight remains unchanged. So this will be still current weight. Now what we want to do is we want to get the maximum value, right? The maximum value that we can get. So you'll get some answer from the left subtree and you'll get some answer from the right subtree, and you want to get the maximum. So what we could do is we can just return a condition which will be get the maximum from the pick and from the not pick. So this was your recurrence relation. Now let's take a look at the base case. The first base case is very obvious, which is that if you get -1 weight, this basically implies that you can't actually take this item, right? So if your current weight becomes lesser than equals to -1, then you want to return int min. Why int min? Because you want to get the maximum value, right? So if you are getting like a int min, like a very small value like -999999999, so no matter what value you get or add to this, this will still be negative infinity. So you won't be actually taking this path at all, you'll be taking some other path. So that's the reason why we added a negative int value. Okay, negative int, the int min value. Now if you um, carefully notice, um, over here, so we know that like this is going to return int min, right? But what about these values? Well, we know that we still have like 3 kg capacity for this one, right? And over here our weights, or the current or the last element, is of weight 3, right? And I can actually grab this item of a value 30, right? So what you want to do is you need to check your current weight, and if your value of this weight, so if my current weight, or better, if my current weight minus my weight of I is greater than equals to 0, then I can take this item, right? And if I decide to take this item, then I can return its value, which is 30. So I can return 30 over here and get the maximum. So you'll get 30. And then over here, you can still pick this item. This will be 30, right? And we also wanted to add another condition, another addition over here, which is that if we are taking an item, then we also want to add its value. So this will be value I. So we got this, and we decided that we're going to be taking this item over here, right? So this will be 30 plus what was item 1, this was 50. So we'll add 50 to this, and we got 80 over here. Okay, is this the maximum? No, because if we pick this item over here with 30 and um, what was it again? It was pick this, and don't pick this, right? So don't pick the first one. Okay, so this will return 30, and then we decide to pick this one. So 30 plus 60, that will be giving you 90. Okay, so the last base condition that we wanted to add was if this, right? And you also need to check before this, we need to check that if if I double equals to 0, which means you are at the last element, either you're going to take this element or you're not going to take this element, and you're going to only take this element if you have space in your bag, right? So this condition over here is checking that do you still have space, do you still have space. If you have space, then add or pick it, pick it. And how are you going to pick it? You're going to pick it by returning value of I. So that is your knapsack. So now let's quickly code this up and go over here. So I have my weight, capital W, and I have my N, which is the amount of elements that I have. The WT I am assuming is the my weights. So let me just clear this up so it's easier for you to write or understand. So let's say that this is going to be my current weight. This is my weight, and this